All right, good morning. Uh, Video over here on the 3D notes, specifically on how to use the Desmos star calculator when we're doing systems of linear inequalities. Again, this is going to be kind of important to be able to use to get the y by itself, because being able to graph these is going to be a lot easier. Okay, so here we have a system of linear inequalities. X plus y is less than or equal to 8. 4x minus y is greater than 6. All right, so in order to solve these inequalities, first we want to do is we want to get the y's by themselves. So let's start with that. Up here we have x plus y is less than or equal to 8. So we need to subtract x and subtract x to get the y by itself. So our first equation, we're going to have y is less than or equal to 8 minus x. Okay. Now here on this other one, we have 4x minus y is greater than 6. All right, if we want to get the y by itself, we'll minus 4x minus 4x. But we're not done yet. We do that. So we have negative y is greater than 6 minus 4x. We don't want negative y, we want y, so we're going to have to divide by negative 1. Now, we need to be careful with this, because remember, with an inequality, when we're dividing or multiplying by a negative, we got to switch the sign. Okay, so we cancel that out. Negative y divided by negative 1. So we're going to have positive y. Now we got to flip this sign. So instead of y being greater than, y is going to be less than 6 minus 4x all over negative 1. All right. So y is going to be less than 6 minus 4x all over negative 1. And the other equation is going to be y is less than or equal to 8 minus x. So these are the two equations that we have written with y by itself. And for here, we've gotten most of the work done. However, when we go to graph these in Desmos, the Desmos calculator will not allow us to graph inequalities. No big deal. What we're going to do is we're going to make the equations equal. So we're going to have y equals 8 minus x. So we'll go over here and do that. So we have y equals 8 minus x. And on the other one, we'll have, where did I put the notes? Y equals 6 minus 4x over negative 1. So there's our two graphs. I'm going to go back and forth between these two graphs here and sort of show these out. If you want to get a piece of graph paper to sketch these out, you can. Did I put a piece of graph paper underneath here? Oh, I did. Okay, so I put some graph paper underneath here, so we're okay. So I want to sketch these out on this graph paper first. So we have y equals 8 minus x. So the y equals 8 minus x graph, I believe, is going to look something like this. Yeah, so 8 and 8. And so we're going to have a shaded line here. And the other one we have y is less than 6 minus 4x. And so over negative 1. So it's really 4x minus 6. I'm just trying to sketch these out. So that graph is going to look something like this. Okay, so we have our graphs. We sketched them out. Set them equal, sketched them out. Now, if we're looking here, if we have y being greater than or equal to, we're going to shade above the line. If y is less than or equal to, we shade below the line. Okay, and our shaded region is what is going to have happen here. So if y is greater than or equal to, we'll shade above the line. Less than or equal to, we'll shade below the line. So let's skip this part just for 1 second here. So here we have y is less than or equal to 8 minus x. Okay, y is less than or equal to 8 minus x. So since y is less than or equal to 8 minus x, we're going to shade below that pink line. All right, so we're going to shade below this pink line here. And so I'm going to do that in blue. So anywhere below this pink line is going to fit that inequality right there. And then the other graph, we have y less than 6 minus 4x over negative 1. So y being less than 6x, 6 minus 4x over negative 1. So again, y being less than over here, we're going to shade also below this green line. I'm going to do that here in red. So we're going to shade below this green line as well. So what happens here, just to sort of color code this, the blue are all the solutions for y being less than or equal to 8 minus x. The red are the solutions for y being less than parentheses 6 minus 4x all over negative 1. So when we do this inequality, everything in the blue is a solution for 8, or y is less than 8 minus x. Everything in the red is a solution for the other one, y is less than 6 minus 4x all over negative 1. All right, so what's going to happen is the area that's shaded by both is going to be our actual shaded area. So the blue is all this area, the red is going to be all this area. So what's going to happen is here, this area here is going to be the solution, okay, the purple. Because this is where we're shaded below the green and we're shaded below the pink. Okay, so any point in this region here is going to fit the solution. Now go back, because I did make one little boo-boo here, but I kind of jumped the gun a little bit. So if we have a greater than or equal to or less than or equal to, we know the line is going to be solid. If we have less than or greater than, the line is going to be dotted. So what really should have happened is this green line should have been dotted. So the green line should probably kind of look like that. We probably learned that in Algebra 1. I kind of jumped the gun, but I wanted us to see the picture before we talked about the dotted line versus the solid line, okay? So any point that's in this region right here is going to be a possible solution. So to recap what we're going to be doing on these things here, we have a system of inequalities. First, get the y by themselves, get the equations equal, and then graph them. So again, what we did is we took these and we graphed y was equal to 8 minus x, and y was equal to 6 minus 4x all over negative 1. So we graph these. I'm going to provide you with graph paper as well. That way you can sketch these things out and sort of figure out your area there and do your shading either above or below or wherever on these graphs right there. And so make sure we follow these rules right here. It's important. So if y is greater than or equal to, we shade above the line. If y is less than or equal to, then we shade below the line. So on both of these, we ended up shading below the lines because on both of these equations, we had y being less than whatever our function was. So we draw the graphs. Now that we have that, we use the graphs to sketch it out. We draw the graphs. We shade in the regions that are supposed to be shaded. So under the pink, we shaded all that blue. And under the green, we shaded all this red. And so this purple region was really kind of where both was. And really, we could have shaded this area red as well because this is all underneath the green. But this purple region right here was the only region that was underneath the blue, or underneath the pink, excuse me, and underneath the green. Okay, that's why I did it purple, because this region is both shaded blue and shaded red. So any point in this region right here would fit the two equations. Now, we could always check. So let's just take a point in this region here. I'm going to take this point 5, negative 3. Okay, 5, negative 3 looks like a point in this region here. So let's check it out. So if we have negative 3 less than or equal to 8 minus 5. So we'll plug in 5 for x, negative 3 in for y. So here we have negative 3 less than or equal to 8 minus 5, which is 3. Well, that's true. So negative 5, 3 works for this function. Let's try this function, or 5, negative 3, excuse me. Let's check this one. 5, negative 3. So we have negative 3 less than 6 minus 4 times 5 all over negative 1. So we have negative 3. 6 minus 4 times 5 is 6 minus 20, which is negative 14. Over negative 1. So what we have is negative 3 being less than positive 14, which is also true. Which sort of validates the thing that, 5, negative 3 is in this purple region. It fits both, and so we did it right. Again, you have this, do this on your handouts as you are finishing the warm-up, and then go ahead and try some of the practice problems. Really, the first 3 are good right there. Pause the video if you need to. If not, I'm going to go on to this next part. Okay, on the next part, it says if no points are in the overlapping regions, and there are no solutions. So let's do these problems real quick and solve it out. I don't want to take a whole ton of time on this one, but I just want you guys to sort of see it. So first thing, 2x plus 3y is less than 6. We want to get the y by itself. Okay, so we got to get the y by itself. So to get the y by itself, and I'm going to move kind of quickly here, we're going to have y is less than 6 minus 2x over 3. There. And on this one, we have the y is already by itself. So we have y is greater than negative 2/3 x plus 4. All right, so we got the y by itself on the top one. Y is less than 6 minus 2x over 3. And we have y is greater than negative 2/3 x plus 4. So again, what we want to do is we want to set these equal. So we'll graph them. So we'll go y equals 6 minus 2x over 3. Oh dear. And the other one is y is greater than negative 2/3 x plus 4. All right, so we see we have parallel lines right here. So we have parallel lines, and I'm just gonna stay on this graph right here because it's easier. So we had our one, even though we have equals, the equation had y being greater than or equal to negative 2/3 x plus 4. So y being greater than negative 2/3 x plus 4 means we're going to shade all the way above the green line, all the way up here. The other equation, y is less than 6 minus 2x over 3. So when y was less than 6 minus 2x over 3, we're going to shade up underneath the red down here. So we see there's no regions that overlap. We have the green region up above here, the red region underneath here, nowhere where these two things meet. And so what's going to happen is there's going to be no solution. So if no points are in the overlapping regions, then there are no solutions. Okay, that should be it. You guys have a good day and holler if you need me.